Hello, hello.
And of course, knowing that it's Sage, is trying to solve them by radicals.
Yeah. But it's really, I think it's really not safe. It's maximum, right? So it's just whatever they can do.
And then when it gives output which is not real, it says that the output is tuple.
No. Because output is not real, it should be the same as if it gives.
Because I actually not.
Hello, hello.
Tuple does not have actual.
That is probably true, but
Hello,
so
hello,
I just
hello.
give it Citron, so I'm just going to do my local computer.
Hello, hello, hello.
Try and figure it out in the next 5 minutes. Yes, but it gives tuple, I mean, it depends, I don't know which software you use, but if there's more than one answer, of course, it will give you more than one answer.
Yeah.
So that could be,
No, no.
so if you're solving something in
the
X.
zeroth answer, and that's
Yeah, I would have to see the specific.
well, I just didn't have enough time to muck around.
Yeah, that's not too bad.
Yeah, those problems were more interesting this time.
Good.
Project Euler problems. I didn't do the IEEE one.
No, that one you just had to read about. I mean, I said try to. Try to create a Sage function which takes a decimal. If anybody who truly did all of the homework, I'd be extremely impressed. Just because there's so many different, unless you'd already done it before, right? So maybe you've already had some experience with.
I do think that 30.
Whoops. Yeah, but to do all of them, it'd be. Oh, thanks. Okay. Now I have two. Yeah, to do all of them, it would be a lot because if it's your first time programming or using Sage. But I wanted to give a wide variety of exercises and make sure everyone had something to do. But yeah.
They were fun.
Yeah, like this one from this algebraic graph theory. I don't even know if I would know. I would have to take a while because I'd have to read the book. And so, did you enjoy the book?
Yes, this book is nice.
Oh, good. Oh, maybe Amri should order it for the library then. I said maybe Amri should order it for the library then.
Oh, this book, I think it is in the library.
Oh, okay. Good. As long as you remember to give it back before you leave, you can have it another couple days if it's useful. Yeah? Okay, good. No problem. I'm done with everything I needed to do from there at this point. Now today we're going to talk about not programming. We're going to talk about.
I could not make the program for 11th.
You did? No. Okay.
I could not. I tried.
I will show you a piece of what might. Yeah. That's the one piece from this that I did actually.
Oh, that one I did and got the right answer.
Oh, good for you. Excellent.
-5, 9,
Yeah, it was minus. Yeah.
70
Oh, I didn't even record that.
Oh.
I just put 8 times B.
Wait, A times B was -5?
No, it was some
Oh.
minus 5, 7, 2.
Oh, something.
4, 2, 3,
I see.
4, 3, 2.
Right.
Yes, -5, 9, 2, 3, 1.
Oh, very good.
3, 2, 1.
I don't know what A and B are.
Oh, because you didn't print that out.
But I still have the program, so potentially I could store it.
Yes, yeah.
Yeah, and I try to give a lot of homework problems that are more about, explain this, or, can you figure out this, or do your favorite this, because I don't want it to all be, if I was collecting them, it would be different.
Oh yeah, I think Vishwanath, we'll only be recording mornings, right?
Yeah.
Yeah, just one session.
One session meeting.
One session means they anyway charge for full morning, right? So yeah, just 10 to 1. Yeah, 10 to 1, 1:30.
So there will be tutorials in English.
Yeah, then it'll be kind of informal. There'll be different activities in the evening. Since mostly it's during the weekend, we can take over various classrooms. We'll have the detailed document. Right now, there's a program on the website,
Okay, it's updated.
but it's not very detailed. Maybe what do you
My class. And I can prove to my wife I actually did some work.
Why? It's just a bunch of people sitting in a row.
That's true. That's right. Yeah, maybe I can ask a photographer to take a picture of me at some point too. See, look, I'm so involved, right? I'm just engaged. Oh, yeah, this is so awesome. Oh, wait, where's my pointer? Where's my pointer? Oh, do you have it? Oh, no, she's getting it. Yeah, actually, Ram Murthy this morning, and Kanapam were having breakfast. They asked me to join them, and so he's like, "So have you gotten to see this? Have you gone to see this?" And I was like, "No, I've basically been writing lectures for this thing the whole time I've been here." He's like, "Oh, you need to get out to all these places." I'm like, "Okay." Oh, great.
Is that was that a complaint? Or?
I don't know. I mean, I'm having a good time either way. So there you go. We're doing a lot of math right now, as you can see. Having a good time doing math. There you go. Not me.
Sometimes journalists come into the institute for various programs. And once there was me and some students, they said, "Okay, now interact."
Yeah, I know. It's like, yeah, that's what. Yeah, they often do stuff like that, right?
I order you to interact.
So yeah. So speaking of interacting, who are we still waiting for? Because Geeta is gone. Geeta is gone, and Shiv is sleeping.
It is coming in.
He is coming. Oh, okay.
Okay, Uday is like
Is there anybody else
chatting
that?
in the corridor.
Vishwajit is here. Yeah.
Uday
Any?
is chatting in the corridor with someone.
I could go shine it in his eyes.
But maybe, yeah, he's coming. He's parting goodbyes. Few last words.
There is, when I was reading about the stuff about Tamil culture, they were talking about how greetings are very important, and no matter how much time you have, how quick and much of a hurry you are, you must do a formal greeting, and there must be some discussion before you can go on to. But I don't know if that's actually true. In a math institute, I really don't know if that's true. So. Are we? Oh yeah, these guys are coming too. They have laptops, so I know. Welcome. I dock you 2 minutes, 2 points. You lose 5% of your points. But there are no points, so. Okay. Okay. I think we can get started then, Amri?
Yeah.
Yeah. Okay.
I'll tell you after.
Okay. All set? Okay. All right. Well, welcome back to the 4th day of our Sage and Programming for Mathematicians course. This is the second to last lecture of my portion, and so soon you will be seeing more about object-oriented programming and other things. And of course, for those who are here for the Sage Days, they will be experiencing the Sage Days live and in person. So today we're going to be talking about sharing and interacting. We're actually not going to be doing a lot of programming. There will be some programming, but what there will be pretty easy, I think. So instead, we're going to talk a little bit about how to share and how to interact using various programs and various interfaces to Sage. And as always, this worksheet too is based on materials used in Math Association of America prep workshop, but not much of it. So we're getting to some really interesting stuff. And so today I hope will be more enjoyable than grueling. But we should talk about last time's homework just a little bit, just to see if anybody, again, the homework is a wide variety of things, some of which are just explain what happened here, others of which are impossibly difficult for someone who's never programmed before. Tried to give a good variety of them. I hope that everybody was able to do this one, just because this is a very mathematical thing, right? By observing what happens with this slice notation with the 2 commas of a list, you should be able to say exactly where it starts and where it. So where does this start? Which index does it start at? It's the A index. A index, right? And remember, the A index is the A plus first element, right? And what does the B mean?
Ends at B minus 1 index.
Right. Or it ends before the bth index. So depending on C.
C is negative.
And C is the, that's right, C is the skip. So if C is negative, right, so there's the question. What happens if C is negative? But where does it end? So what if I had 1, 5, minus 1? 1, 5, and then a skip of minus 1. What will happen? So it'll go backwards 5, 4, 3, 2, but not 1. Are you sure it won't be an empty list? Huh? Empty. Yeah, I think it will be empty. Well, we have to find out. So try it out right now. Try it out. So, because we need a difference between 5, 1 minus 1 and 1, 5 minus 1, right? So which one will it be? Okay, so see, there's lots of subtleties involved. One of them will be empty. I forget which one, actually. 1, 5 minus 1 will be empty. It starts at 1.
Which is already less than 5.
Exactly. Right. So if you wanted to get 5 through 1, would you have to do 5, 1 minus 1? Does that work? I mean, let's find out.
You get 5 to 2.
Okay, good. So that's what I thought. So it's very subtle, right? You have to think about things like this.
So what is the meaning of LS?
Oh, just any old list. Sorry, that was, I'm sorry.
Not Sage then.
No. The LS just meant pick a list. Sorry about that. Yes, that would have been a great question for office hours or an email over the weekend or knocking on my door at the hostel over the weekend. I don't know what LS is. Okay, so you see there's these subtle things. And then the same thing here, can you find, there's actually quite a few methods of M that do the same thing as the slicing notation. And they're more explicit, of course, so it makes it easier. I hope that this was fairly straightforward. Excuse me. Excuse me. Let's see. Which ones are interesting? Oh, 5 and 6. Can you tell whether the square of the input is between 3 and 4? So probably you had to join 2 different things to figure that out, right? You needed like a squared is greater than 3 and a squared is less than 4.
If you write if 3 is less than x squared,
Less than
4.
Yes, so there are several different notations. So you might be able to combine them into one notation. So you see that there might be more than one way to solve these even then. I would use the and to be explicit because sometimes that works and sometimes it doesn't. But in this case, it does work. Say good. Yeah. And I hope that there was a connection between the primes congruent to 1 modulo 4 and those that you could write as a sum of squares.
Odd primes are same.
Yes, odd. Yes, of course. Very good. First, so 2 doesn't work. Right? 2 doesn't work. Good. And what was the other connection? So 2 is in the first list but not in the second list. Actually, sorry, 2 is in this list and not in this first. Right? And otherwise they're the same. Right? This is this theorem, right? Yeah. So, but it's kind of fun. And this is, again, you can do this by very brute force method and just have a list of all a squareds and b squareds and then let C equal a squared plus b squared, C dot is prime, right? So that'd be one way to do it. Or there is a function is prime. So see, there's a method is underscore prime and there's a function is underscore prime. And so those would be, anyway, so, and then the only other really important thing I think is did you try to use dictionaries and could you explain what was going on in the examples with dictionaries? Dictionaries are a very important input method for things that are sparse or things that are, yeah, because I mean, even though a graph isn't sparse, compared to the complete graph on 20 vertices, most graphs you will care about on 20 vertices will be sparse. So it's a very important thing to do. We'll talk about this Project Euler problem in a little bit. And the rest of it is just for fun. I mean, not just for fun, but it's not that exciting. This last one is going to bring us into today. Can you make a worksheet or a script that calculates something, and could you do it well enough so that you could teach it to someone else? And the someone else is the point of today, sharing and interacting with Sage. Okay, so of course mathematics can be this solitary occupation, and in the port of Chennai, Madras, Ramanujan's sitting there, and after a long day at work, maybe not so long day at work, he's doing all this math completely by himself, right? But that's not really how mathematics happens, right? Most mathematics, there's people engaged. Of course, you do a lot of it on your own, but then you talk to somebody about it. You share a preprint with somebody. Maybe you ask them, hey, is this a well-known result, right? Is there some lemma I really need badly? And so talking to people about math is really important. So this tutorial is going to talk about a lot of interactive capabilities of Sage, as well as ways to share our stuff. So let's start with sharing your code. Everybody ready to share some code? Yeah? Maybe? No, you're not sure. You're hesitant. I sense that people don't feel like their code is good enough yet to share. That is not true. It's always good enough to share, just as long as you share it with the right people. But let's look at, there's these, you just have to be careful, don't. So here are 4 ways to interact with Sage, right? There's the Sage Cell server, it's just the one-off computations. There's this math cloud, which we're not using, but which many people do. Command line, a terminal, and then the Sage notebook where these tutorials live. Okay, so what you want to do then is take a look at the different ways that you can do it and what are the different ways to share. So I've provided links on a few occasions to Sage Cell instances. So how did I do that? So I'm going to show you this graphic. This is actually an image. This is not live. Let me just shrink it just for a second. So you can see on the cell server, I did this very silly thing. I said truth equals. Now notice there's 1 equals here and 2 equals here. I concocted this example just to show you could do it. Truth equals, and then this is a Boolean expression. 2 plus 2 is equal to 4. Right? So truth is assigned to the value of whatever this is. So 2 plus 2, does it equal 4? That's the question. And then I printed, is 2 plus 2 really equal to 4? And then I print truth. So I'm printing out the value of this mysterious statement, 2 plus 2, is it equal to 4? And apparently the answer is true. Okay? And you'll see what happened is that there's this share link over here on the upper right above the answer. And if I click on that, I get 2 links, and I even get a QR code, believe it or not. So if somebody has a smartphone right now, you should be able to use your smartphone right now to click on this link. I think. So if somebody wants to try that out, you can. I don't have a smartphone, so I can't do it, but I hear it works. So yeah, try it out. And the point is this little share thing here. The links here are basically both useful, but you can embed that in any web page. You can send it as an email. So if you have a long or a short computation you want to share with somebody, you can just share it that way. Is anybody doing it right now? No? Otherwise I'll scroll up. Yeah? Okay. All right, then I'm going to go to the actual Sage cell. No, and I have to log in with my Wi-Fi because, oh, I shouldn't have to though. I thought I was also in the landline, but one moment. Now watch, if I turn this off, maybe it'll not like me, but no, it's still, I guess I still have to sign in no matter what. It doesn't like my computer. Okay, great. Sorry about that. So if I do this, even if I want to share something as simple as 2 plus 2, I'm going to evaluate it, and then there's this share, and you can see it comes up. And right now it's verifying what the links are going to be, and as soon as it's verified them, then I'll be able to click on them. One of them will be very long, this permalink. The short temporary link will be short. And the point of that one is that it's short and it's easy to put in an email. And right now it's not loading up, so I'm not sure what this, there's still some connectivity issues, although it did get the answer. And so the short temporary link is good for a short one. It does have the potential of eventually being disabled, right? Because it comes from a database inside of the Sage Cell server. So if it gets restarted or something, it could disappear, but not probably soon enough for you to care about it. The permalink here will always work because it's going to be this really, really, really long string that actually is the code hashed. So it's not encrypted, it's just encoded. It's, you can figure out how it's encoded. But the point is then it's a thing that's unique to your computation. And if you did a different computation, like 2 plus 3, then you would get a different one. Now let's see if the share link. Yeah, again, I don't know why it's not working here, but you can see that it worked fine just a couple days ago from this very same computer on this campus. So I don't know what. Yeah, I don't know what the problem is there. So the point is you can just paste it or whatever, right? And for such a short computation, they'll probably be fairly similar in length. But sometimes you might have a very long computation, and then the link will look like 50 lines long or something. So then you're going to want to use this short temporary link, especially if you're sharing it with someone in an email. Okay, so that's how to do it with the Sage Cell server. And links you can use anywhere you can use links. So it's very easy. Now, the Sage Math Cloud, apparently I can share projects with people. Yeah, did you know I had shared a project with you, Henri? No, yeah, see, there you go. So I'm nefariously sharing this project with him. In the notes, I've made this anonymous, but so you can see I haven't said who I'm collaborating with. And so in the settings on any given project, you go to collaborators, and if you know their email or the name that they have in there, and you can just search, and you can have them collaborate it, and then you've shared it. It's not possible to share with the outside world, and again, it looks like I have some nice slow internet waiting for me here. So it's not coming up right this second, but this is what it's going to look like. And so that's it, you've shared it. You can't share it the outside world though. See, so the Sage Cell server is a nice way to share with anybody. You just give them this link and then they get there. This way is if you're privately collaborating, especially on a paper, because in a project you can have LaTeX files, you can have Sage files, you can have all kinds of different things, and then you can collaborate on the entire project. And then when you're done, it really, when you says has co-authors, they really will be co-authors and not just somebody who added a couple of lines that you couldn't figure out or something, right? But you're both working tirelessly on this. I think eventually the William Stein wants to add the possibility of sharing with the outside world, but the question is how do you do it without the possibility of things like cross-site scripting? There's a lot of ways that hackers can get access to databases, and the Project Euler, in fact, which we've been doing many problems from, somehow a hacker was able to get at their entire database of emails and passwords. So that's why you can't log into it anymore to kind of have an account where you share things. And so in order to make sure that doesn't happen with Sage, they're currently not making that possible. Okay. All right, so now I can look at my list of files if they have a list. And there we go, so there's my demo worksheet. And then if I go up to settings here, you can see there's different things I can do. And one is, so I could add another collaborator. If somebody here is on Sage Math Cloud, I could take their email address, type it in, or their name and type it in. If you knew what name they had chosen on the cloud, of course. Okay, now there's more to sharing than just web interfaces. So of course, many of you and many of you out there in TV world will be doing all kinds of you'll just be doing stuff on your own computer, right? You have something you're trying out, and maybe it works, maybe it doesn't work, and you might be doing it on the command line. So you might think, well, how do I share that, right? Maybe I just wrote some really short thing, and that's just on my computer. Well, but you can share files you create on your computer via email on the web, right? So you can either put them up on a website for download, or you can actually perhaps share the text of those files. So here's one of the ones I didn't talk about from the homework. This is one piece, perhaps, of solving one of the problems from the last homework set. So this is a function called define get consecutive primes. And so how do I get those consecutive primes? I'm going to have two inputs, right? So I have a and b, and those are going to be the coefficients of x squared plus ax plus b. And if you remember the Project Euler problem, the problem was to find a polynomial that if you put in consecutive integers, you got a whole bunch of prime numbers. Okay? So I'm going to let that be the formula. For any given coefficients a and b, the formula will be x squared plus ax plus b. And then I have a control statement, if else, so if colon and then more indentation, then otherwise more indentation. So if not is prime formula 0, what does all that mean? It means if I plug 0 into the formula, and if is prime is true, oh wait, if it's not true, right? So you'll have to read up a little bit on Boolean expressions to see it, but you can parse this thing. If it's not true that formula when you plug in 0 is a prime, then print the formula and print -1. Okay? There were -1 of them in a row. Otherwise, I'll let n equals 0. And then while, this is a new construction, which you may want to read up about, while the formula at n is prime, I'll just keep on incrementing. M plus equals 1. That's a short way of saying add 1 to n. And you will see many short ways to add 1 to n. So this is a place where having access to the various programming tutorials of the Python world, which I couldn't possibly cover all the things you need to know, in a short period of time, is really helpful. Just how do you do really simple things like make something bigger? Okay, you make something bigger by doing plus equals and then how much bigger you want to make it. So as long as this happens, I keep incrementing. And then as soon as it's not prime, it stops incrementing. And that's the last n. Then I'll print the formula and I'll print n. And lest you doubt that this works, if I get consecutive primes with x squared plus x plus 41, there are 40 of them in a row, which is exactly what the Project Euler site gives as the example, right? Euler comes up with this very interesting formula. Or maybe not Euler, somebody else. And then if I try x squared plus x plus 42, you can see that I get -1 of them in a row. Oh my gosh, that means that there's none, right? Well, that's one problem, right? How about 4? Right? If I do it with 4, also none. So you can kind of experiment a little bit, right? So there's all kinds of things that you can do. So if I was using this and I wanted to share it with somebody, right? Or maybe I just needed some help checking that it actually works. Or maybe I just needed help checking values because I have to type them all in by hand. Oh, it's so horrible, right? And so I need a huge, monstrous group of people to help me check where are these primes. So let me zoom in again. Oops, not that much. In that case, what I can do is I can actually cut and paste my code to a file. And I can send that file out into the world and post it on a web page. And so here it is. So here's define get consecutive primes. I just cut and pasted this. This is all it does. All that this script does is defines this function. That's it. But that's all I need. I need to send it to somebody else. And you'll notice I've saved it as GCP get consecutive primes dot sage. That tells Sage that this is a Sage thing. And in particular, syntax like this is illegal in Python. This is a kind of a syntactic sugar, as people like to call it. It's a sweetener to make Sage more palatable. Just a spoonful. And formula of x equals this. That's the way we would do it in math. But that's not normal programming syntax. So then I have this file. And so it wouldn't know what x is. But Sage knows that x is automatically a variable. Right? So those are several slight differences. And so you don't want to have to worry about that. So just call it .sage. And then if I send it on, the other person knows that it's going to be .sage. And I can just run it, and they can just do whatever they want with it. They can use it in their command line. They can use it somewhere else. And so here's an example of this. So here, this is in my actual command line. What I did is, here's where I had downloaded gcp.sage, or I had written it. It was in this directory. And I do have to give the exact syntax of the exact location. And you can see, I just loaded it. Load. And then I put inside quotes the full directory path. And then get consecutive primes is defined. You can try out on your own Sage that get consecutive primes is not a real Sage function. It's only because I loaded this.
It's also worth noting that you can give a URL here, HTTP.
Yeah, you can. Yes, that's right.
Very convenient.
Yes, that is absolutely right.
So this is on your computer or in the web? This on the download. This is already saved.
So currently what I've done is I've created this file, gcp.sage. I saved it somewhere, and then I loaded it in my command line Sage. But I could send the file to someone else. I could put it on a web page, and they could download it. And as Omri points out, and let's actually, I guess I can't try that because I don't think I uploaded this to the web. But in principle, if you had a command line and this was on the web, then you could go to that URL and place that in here and use it directly from there if you were connected to the internet at that time. Yeah? So it's already a good way of sharing it. That's just using kind of functionality behind the scenes of Python to download things.
Since you loaded from a state session, do you need
Yes, louder.
Since you loaded from a state session, do you need the extension to be .ch as well?
Yes. Yeah, because otherwise it's not going to know. It might be a Python file, or it could be a shell script. So in order for it to know that it's .sage, the Python inside Sage has to know that it's, because otherwise it's not going to load up things like x being a variable predefined and other.
Also, just starting a state session won't necessarily.
No, a Sage session will do that. No, so of course in a Sage session I could just type this in. That would also be okay, right? But that's a lot of work. Even cutting and pasting this, making sure that the indentations are right. Instead, I can just say load this one file and all that's done. And of course, this is a short file, but now imagine it's hundreds of lines long.
No, what I'm confused by is, so I thought you were loading it within a Sage session, right?
Yes.
You started a Sage session. So what's the difference between, so I start a Sage command line and I type all these in?
Yeah, there would be no difference. That's right. Yeah.
And
This is just easier. But I'm pretty sure if it doesn't say .sage that it might interpret it as something else. I don't think it automatically interprets all files that you load as Sage files. It could, for instance, it could interpret it as a Python file. And then it might not do all the same stuff. Yeah, I believe that's the case. So someone out there, if I'm wrong, you can put a comment on the YouTube channel. But I'm pretty sure that that you want to be just careful about that.
It loads Python file as well. I don't know whether it gives error compiling the command.
It gives an error when?
You can load a Python.
you can load a Python file.
Yeah, yeah.
But I don't know if you put the comments in Python, whether the functions are called or not, that I'm not sure.
I don't think the power thing is going to work either. I think basically just use .sage. I think that is the answer for now. Unless it's a Python file. Yeah, for now, just be careful and just use, there's just these very subtle things.
File, I guess you could use.
You can use a Python file because it will turn it into, this Sage file is turned into a Python file actually. So you can load a Python file, but you just want to be careful because this is not a Python file. So you can load a Python file, that's no problem. But then it would have to be an actual Python file, I think. I don't think you could load a Python file that wasn't a Python file. Because what happens with this .sage is it gets pre-parsed. So when you do the .sage, the thing inside of Sage that does this is very technical for those who are out there, by the way. So you can just skip through this part. The part that's in there is pre-parsed. It's turned into a Python file internally. And in fact, somewhere if you look, there's going to be some temporary Python file that this creates that will have these things done properly. I'm pretty sure. It doesn't have to, but it just does, even though it's in the Sage shell. Yeah. Remember, we're all beginners, or we're pretending to be. So let's baby steps. But yeah, you can do lots of complicated things by doing Python files. There's also this command attach, which is very similar, except it monitors the file for changes. That's really useful. So I've used that quite a bit. You did something, and let's suppose that instead of printing -1 when there's none, I want to raise an error. Or maybe I want to print you suck, or something like that, or whatever. And in that case, then I would change it, and if I'd used attach, then it would automatically update, and then it would start printing out, it would start raising the error, for instance, if I had changed it that way. So load and attach are not the same thing. Yes, that's right. The syntax for that has changed slightly because of some internals in Sage that we've updated, and you can look at the current documentation for that. So basically the whole discussion we just had the last 5 minutes is this discussion. Okay, don't save your scripts as Python files unless you know what you were doing. Okay, good. You can also even save and load complete command line sessions, but we're not going to cover that now. But that can also be very useful if you've created some large objects or something like that. Then it will save everything that you've done in this session file, and it could be ridiculously large if you created several megabytes of files or something. Now, what about the notebook? Here we are in the notebook. So we've talked about 3 of the 4 ways, and of course this is the notebook. And there's a lot of things you can do to share in the notebook. So you can always download your worksheet. If I go to the worksheet from last time, and I go up here, if I go to Action and file. So file here, I can actually, save worksheet to a file. So that's something that I can do. It doesn't work in Safari very well, or at least old versions of Safari for some reason, but most of the time it works fine. And if I didn't want to, then I could just go over here, and then you see I can click on it, more random stuff, and then I could download it, right? So there's all kinds of things that I could do to download such a file. Oh, and then of course I could upload the file as well. So if I go here, then I can upload lots of stuff. An SWS file, that's the thing that a Sage worksheet downloads as. But you can actually also upload text or HTML. You can upload the URL of a page of the Sage documentation. So the Sage documentation is formatted correctly that it will parse it correctly to turn it into a Sage worksheet. And you can have a zip archive of any of the above. So you can download all the things from an entire course's worth of notes and zip them up and then upload them up to your thing. And then all of a sudden you'll have 50 new worksheets from all the things that you uploaded. So there's lots and lots of different things that you can upload. And then of course, it's a graphical interface, right? So I can call it something else. There's lots of stuff you can do with sharing it. So it's not super efficient, but especially if there's not lots of back and forth involved, it's actually a very good way to share complex code or research code. Also a good way if you're only distributing things to students or only having it distributed from them, another good way because it's a one-time thing. It's just not very efficient for in-time collaboration, for which the Sage Math Cloud might be a better option. If your collaborators are registered in the same Sage Notebook server, you can also share with them there. So if I go back to my home here, and let's go to Programming Tutorial 2, if I click on Share, I can add collaborators. Currently, the default is that it doesn't show you the list of all possible people, but I'm going to ask Amri, what's your username on Citron? Just okay. So I'm going to invite this collaborator, and hopefully it works. Let's see. It's not telling me that it's shared yet, so it's possible that maybe that wasn't actually. Oh, it's not. Haha. This is my local. Right. So if the internet was working on this computer right now and I wasn't on my local computer, no wonder it was an error because there is no Omri on my local computer, or there better not be. I'm in trouble if there is. Yeah. So there's some intranet problems here right now where I'm not able to connect to the Sage server. That's on here. But if I was, and let's see, maybe it's up now. Oh, hey, now it is. So let's see if we can do this. All right, here we go. So now I'll go to the Programming Tutorial 2, and I'll go to Share with Omri. All right, and so now, apparently it's shared with Omri. And if I take a look, see, there you go. It's shared with Omri. That's pretty cool, huh? So that's something that I've used as well with my students when we've been doing some summer research. Just an easy way to do things, as long as it's not a really intense, real-time collaboration. It's like, every day or something, every couple hours. It works out pretty well. Great. So now we're online with that. All right. If your server allows it, you can also publish your worksheets and allow those to be viewed with the rest of the world. That's something that a lot of places have turned off now because of the possibility of again, cross-site scripting type things. Here's some published worksheets that people have shared from a workshop that I ran. You can see various people here. When Sage meets elliptic curves, interact, quick start, discrete math, lots of different things that people did. So it's certainly possible to share in that way as well. You just want to be careful that whoever is on your server is somebody who's trustable. You don't want to allow completely arbitrary, because they could put arbitrary HTML into them, or spam, or all kinds of other crazy stuff, and you don't want to be liable for that. So that's too bad. Okay, I think I talked about all these things. Oh, right, but I didn't talk about this other way. So you can share in the notebooks in yet another way. So what I'm going to do is I'm going to reset. I'm going to make sure get consecutive primes gives me an error. Okay, good, it gives me an error. Right? Now it's no longer defined. Now I'm going to load it from inside the notebook. And now it works. And so what I did, so this I'm going to show you what I did. What I did is I went up to the very top, and under data, which is a good place to put data, you can see that I can put a few things. I have a few pictures that I use to show you pictures of how to do stuff. And there's this gcp.sage. And if I click on it, it shows me gcp.sage. It's even got nice syntax highlighting, and I can even change it on the fly. Maybe I won't do that today, but you can see, you save changes. So that's really convenient because I can upload that file to my own notebook. And let's go back to the worksheet.
So data is also like Sage file.
Data is whatever you want it to be. So I put some PNG files, some pictures. It can be a Python file, and it'll pre-parse it. It can actually also be just data. It can just be raw data, like a CSV file, comma separated value. That's a very convenient thing if somebody's giving you a spreadsheet of data that you need to parse. That won't happen as often in this context, but in the data analysis context, you've got some list of the average test scores at 55 different schools or something like that, cross-listed by gender, ethnicity, and all these other things. Pretty soon you're going to need to have a strong way to parse that. And so uploading it to the worksheet and then using it as data, raw data, is really good. So in summary, there are a lot of ways to share your Sage code. It's up to you how you want to do it. I like the notebooks, so I tend to focus on those, but many people are command line aficionados. For those who use Emacs, there's a whole Sage mode in Emacs. Okay, Vishwanath all of a sudden is like, oh, Emacs, that's good. Yeah, you can. It's very easy to download. It's on Sage.
Just do Sage Sage underscore.
I don't know how. Oh, I see what you mean. Yeah. So there's actually a Sage package that downloads it as well, but I don't know how to get it to work in your. I'm not an Emacs expert. I've never used it. It scares me. Plus, I have a Mac, so doing the meta characters is kind of hard. And but for those who want to, Sage mode, right? That's you out there, world. All right. So there's lots of ways to share stuff. But how do you interact with your code? Everybody's still looking at this Sage mode now. They're all excited about being able to use Emacs.
I never want to leave Emacs ever.
I want to stay as far away from Emacs as I can. That said, I'm not a Vim aficionado either. I use Nano or Pico because I need the little help things at the bottom. So that's right. That's all I can do. So how do you interact with your code? So it turns out that Sage is a really nice way to interact with your computations. And the reason I put this together with what we were talking about is because it makes it more worth exploring together as well. So once you're able to interact with your code in a kind of real-time way, if you share that interaction with somebody else, it's all the sweeter, I think. So this is really fun for me. There are many places you can look for examples, and I encourage you, once I've posted this up to the Citron site and to the website for the course, to look at these different places. The Sage Wiki, there's some code snippet sharing, and then there's the documentation for doing interacts, as they're called. Hush in the peanut gallery. All right, so let's do a first example. I'm going to do something very simple to show you this interactivity. And the reason is that not because I think you guys need really simple examples, but because doing something everyone is familiar with and that's very straightforward is a really good way to figure out how this actually works. And we're going to plot graphs. Okay? That's all we're going to do to start off. So first, let's remind ourselves what the commands are. I'm going to just remind myself. If I plot x squared, here's the syntax for the boundaries, right? I put x, the variable, and then the boundaries inside of a tuple. And then I'm going to add this fig size keyword just because the projector here zooms in so much. And so it's hard. If you let the default fig size come through, it's going to be too big. So I'm going to add that. That's just so it looks nice in the screen. That's not really necessary. Now, here's the part that's universal. Anytime you want to make this interactive, I need to abstract out the things that a user wants to interactively change. Let me repeat that. If I want to make this something that anybody can look at, think about what you want the user to change, and then abstract those things out. As mathematicians, we're used to that. Okay? Others who use such visualization tools are maybe not so used to abstracting things out. But we are used to doing this. So let's start with this. So first I plotted x squared. But let's abstract out the function that I want to plot. So let's say it should be x cubed, or maybe whatever I want. So if I let f equal x cubed, and by the way, here it's not technically, here it's a symbolic expression, not a symbolic function. And then here I'm going to plot f. So instead of x squared, I just replaced it with this abstracted out thing, f. So now it can be whatever I want. Everything else is the same, right? So if I went back up and I went to x to the fourth, it would plot x to the fourth, right? So whatever I want. See, it's like the beginnings of a function. And indeed, I can now make a function out of it. Again, I haven't done the interactivity really yet. I'm going to make it a def function. I'm going to make the default value also. I'm going to give it a default value of x squared. So f equals x squared. Everything else is the same. Plot f endpoints fixed size. So this part right in here is exactly the same as it was before. I am doing show, because if I did a def my plot and I didn't do show, then it would just create the plot, but it wouldn't show it. Okay, so that's why I have to do that. All right, so I have a new function. I'm calling it my plot. Default is that the function is x squared, and then I show the plot of x squared between minus 3 and 3. Does that make sense? This is the part that, yeah. So you've all done some definition of functions for the homework, so hopefully it's okay. Now I'm going to test it. It seems to work. This is a different function, right? 0.01 times x squared, and it's correspondingly 100 times shorter. 1/100th as tall. So it seems like my function works. Okay? This is the first step in making interactivity. First, make sure you have a function that actually works. Okay, now let's try, well, let's see if it works again. All right, x cubed. So this was all review, right? I'm just defining a new function. How do I make it interactive? Easy. I just put @interact before that. That's it. @ interact. This is technically called a decorator, and if you want to learn more about decorators, there's way too much information about them on various Sage documentation sites and elsewhere. Kanapan says, yes, yeah, but I don't know much about decorators, so I'm not going to. There's a parallel, yes, so if you want to do parallel computations, there's a parallel decorator. There's an options decorator, which can pass in default options. But I won't talk about any of those today, just parallel. All right, just interact. So here we have interact. Now I'm going to change that to x cubed. I had x squared, here's x cubed. All right, everybody sees it? It just magically changed. Wow, that's amazing. X to the fourth, x to the x. Oh, okay, so x to the x, of course, has some problems at 0 and negative numbers. But that's actually pretty impressive that it did that. What about sine of x? Okay, yeah. Didn't quite get to pi. Gee, wouldn't it be nice to make it go to pi just in this one case? That would be nice. But apparently I can't because, I can only change the name of the function. Yeah. So it's fun, and you can do all kinds of different things. And yeah, so there you go. It's interactive. Wow, I made something interactive. And all I had to do it was to make a definition of a new function with an interactive default variable, and then I put this @interact.
Is it possible to change
To change? Is it possible to change the range? Is it possible to change the range? In fact, that is the next thing that I'm going to do. So the answer is absolutely. It's possible to change anything. Anything you want to make interactive, you can make interactive. And that's kind of exciting, right? Because then you can share it with anybody that you want, and they can just start doing it. And of course, it's also useful for you, because you might want to explore a little bit. So that's what I'm going to do in this very next one. I'm going to change it so that instead of x minus 3 to 3, I'm going to abstract those out. A equals minus 3, b equals 3. Okay? So you'll notice I'm using the same values as I did before. The b just goes up here and is b equals 3. But now it's going to be something I can change. Can anybody see what the other change I made is? The underscore. Yeah, that's right. No, the a we already talked about, actually. I've just changed the name of the function to underscore instead of my plot. The only reason I do that is that's just a convention in Sage, is because it doesn't actually matter what the name of the function is. If all I'm going to do is interact with it, then we call it underscore. Now, you may actually want to use the function myPlot, in which case you probably shouldn't call it underscore. That would be really bad. But if all you want to do is interact, then this is a little easier than having to come up with a name every time. And as you can see, if we now do sine of x, I go from minus pi to pi.
Look very different. Pi is almost 3.
Yeah. Well, it doesn't look really different, but at least it reaches the x-axis again, right? That was the goal. So does that satisfy you?
This
Yeah.
is interesting. So you just define any old function after the interact,
Yep.
and then it just runs that.
Yeah. But with whatever you're,
If you define 2 functions, what does it do?
you don't. You can only do one. Yeah.
So maybe with tuple, you have some.
What tuple?
No.
Like a pair or something.
So we have some command for here. Pair function or what? That will. Maybe that will.
I mean, I'm not sure what you're asking, so I guess I can't quite answer your question. If your function has 2 outputs, that's fine. I mean, you can interact with that too.
Oh, if acting on a pair.
Oh, you mean if you want f of x squared plus y squared?
Yes.
Yeah, you can do 3D plots in interacts, of course. Yeah. I mean, you can have as many inputs as you want to this. And this is just an example. And I'll show you lots more examples in just a few minutes.
So my question is, can you plot 2 curves?
Yeah, of course. Sure.
Yes.
Yeah. And there's a couple different ways to do it, but I'm going to do the simplest way. Okay. So now they aren't going to look too different now, are they? But okay, there. Okay. Yeah. You can do anything like that. Yeah, no problem. I wasn't sure what you meant. Yeah. We can do all of these things. There are many, many things that we can do, but I'm not going to do it. Now what? Now I just made a mistake. Right. So now I have to go back here. Okay, now there's even more customization that I can do. So for instance, what if I want to give these labels are kind of silly. A and B, what does that mean? I don't know what A and B are. They don't really describe them very well. Plus this F isn't typeset nicely, right? Then we should fix that. So if I pass, instead of the control just being x squared, if inside of parentheses, so a tuple, if I put the label in quotes and then the default value, then the control will get the label. So here I'm going to let f be, instead of just x squared, it'll be latect f and x squared. And a isn't going to be called a anymore. It's going to be called lower, and it'll start at -3. I guess I could have just called it lower, but I don't know. I wanted to change as little as possible in my code. So if I do that, got to click on the correct thing. Okay, so now it's a little bit better. So this is typeset. And now these are named kind of sane things that actually make sense. So you can do all of these things. It's not much harder. But you see each step is a little bit bigger. So if I had just shown you this is the first example, you would have said, what the heck is going on? But you see it's incremental development. So these interacts, it's very important to be incremental about how you develop them. So that's nice, but what else can I do with this? Let's search for theorems. All right, this is like my favorite graphic ever. Inspired at least partly by Brissot and Wagon's book. This is a table of prime powers, believe it or not. So in the field of 6 element, right? So Z7, we look at the elements that are non-zero. These are the powers. So this is actually, unfortunately I didn't label it correctly. So this row is the 1 row. So 1 to the 0 is 1, 1 to the 1 is 1, 1 to the 2 is 1, 1 to the 3 is 1, 1 to the 4 is 1, 1 to the 5 is 1, 1 to the 6 is 1. 2 to the 6 is, by Fermat's little theorem, 1. 3 to the 6th is 1. 4 to the 6th is 1. 5 to the 6th is 1. And of course the 0 power of any number is 1. So I have 3 theorems. This theorem says that 1 to any power is 1. This theorem says anything to 0 is 1. And this is Fermat's little theorem. Of course, that's not interactive, right? Maybe I don't believe it. So let's try 19. No, looks like it's still true. 43? Fermat's little theorem. Anybody see any other theorems? No?
Maybe the quadratic reciprocity if
Well, you could, if you really wanted to, quadratic reciprocity is probably in here somewhere. But these aren't Legendre symbols, right? So
Right.
you might be able to find, yeah, from -1 and this, I call this column the square root of Fermat's little theorem. I hope it's kind of clear why.
Kind of, there are only two colors.
Right? Yeah, because this is the p-1 over 2 power. And this is the p-1 power, and so p-1 over 2, square root of 1 is -1 or 1, right? You can also find the theorem that every prime has a primitive root in here, because there's always a row that has all the colors. Now that's hard to see with 43 of them, but if we go back up to 7, which rows have all the colors? This row, right, and this row, which corresponds to 3 and 5. So now we know that 3 and 5 are primitive roots mod 7. So this is the kind of interaction that I just really get excited about, because you can think,
How do you get a drop-down list for P?
what a great question. That was the very next thing I was going to talk about. So how did I get something other than just a box? Well, there's lots and lots and lots and lots and lots and lots and lots of things that you can do for interaction. In this case, what I've done is I've taken the default value of 7 and then put it with a list. So prime range 50 gives you the list of the primes up to 50. And that list will turn exactly into this drop-down thing. So whenever you feed it a list, it'll give you a drop-down box, unless you have very few options, and it'll give you buttons. Well, that's pretty cool, huh? And we just talked about this. There's many other control types. So, Amri, this is the question you were just asking, right? If prime range 50 is the value, then I get a list of primes less than 50. And then there's check boxes, grids of boxes, color selectors, sliders. And the documentation for interact is quite thorough. So now we can go back to our return, get these consecutive primes, and I can actually, explore with different things. And actually, there was one that I found with 5 and like 17 or something that was fairly good. Yeah, so there's 8 in a row, right? That was just by me exploring when I was trying this out the other day. So it's possible to do some exploration this way. It's not really that efficient yet, but it's a lot better than retyping it all, right? And it's a little more fun, too. That's the interact. Oh, yeah, so here's the interact we did before. What if I want even more evaluations? So if I give a list to yet another control, here's a list of 4 strings, then I can get different line styles for my plot, including the empty line style, which is not quite as useful, but it's there. It's there waiting for you to use if you want to use it. Or here's a range slider. So I could customize how much I want visible along the vertical axis. So maybe I don't want 0 to 10. Maybe I want, maybe I only want this much to be visible, which of course isn't very useful for x squared, but might be useful for x cubed. Okay? So I only want the stuff between -8 and 3 visible. -3 visible. Lots and lots and lots and lots of good stuff. In the Sage Math Cloud and the Sage Cell Server, you can even nest interacts. You can't do it in the Sage Notebook. That hasn't been backported. And the syntaxes, I believe, in these two are slightly different. They were implemented by 2 different people. So I'm not going to cover that because of those discrepancies, but you should try it out if you care about nesting these things.
What is the nest?
It means you could have an interact where the controls depend on other controls. That would be really useful, right? Like if you have if you get a number that's prime, then maybe you want to do more stuff and you want to give more options. If it's composite, maybe you don't care about it as much.
Or like if you say country, United States, list of states.
Yeah, exactly. Yeah, that's right. Absolutely. Yeah, absolutely. So depending on the country, it gives a list of states. If it's a country like Liechtenstein or something, maybe it's not really relevant. And so there's all kinds of a gallery of things. We have maybe about 10 minutes left, so I'm not going to go through everything. This is one of my favorites that I've created. I have to zoom out a little just to see this. This is part of the proof of quadratic reciprocity. Somebody mentioned that before. This is, by the way, not the Gauss proof. This is the Eisenstein proof, or one of the Eisenstein proofs. It's just, you can actually count things and visualize, and I don't know, I love it. Maybe you guys don't care about visualizing proofs, but I think it's a lot easier to understand why a proof works if I can visualize it. and try it, especially because like if they give you a picture for a proof in a book, it's always just that one picture. Well, great. So maybe you want to see how it changes as you give different inputs. And quadratic reciprocity, these proofs using point counting and then modulo 2, it's actually a very subtle way to prove quadratic reciprocity. And I think it's not very intuitive why this actually works until you start looking at a lot of pictures. Oh, and of course, everybody loves the prime counting function. So, you know. Oh, now I've added this update checkbox. So if you don't want things to happen right away, maybe I wanted to update the beginning of, and I want to update the end, then I can click this update box, and then it'll wait until I'm done. Okay. So I use auto update equals false, and you can take a look at these examples when you're done. Convenient way to delay the updating. Oh, there are so many more that I could do. Matrices. With matrices, you probably want to not have an auto update. So here I'm plotting all the eigenvalues as complex numbers. I'm just coming up with, this is totally random. I have no idea what I'm doing. Let's see what happens. Okay, so unsurprisingly, the complex eigenvalues come in a pair. Okay, so again, eigenvalues. And of course, if I make a symmetric matrix, then what do I expect? Everything's on the real line, right? Okay. And this is something that will convince a student way more than a proof, by the way. Some of you may actually have to teach real students someday. All right, I'll skip this next one. It's kind of fun. Here's another one, which I may also skip. It's related to dynamic. No, I just have to show you. I just have to do this. I'm sorry. This is just too cool. This is Newton's method, right? And of course, I picked my initial guess for Newton's method in such a way that it's not going to, right? You know, it's like it goes up to 3,000, but you can see the approximation it got is still 10.9. You know, that's just what Newton's method does, right? It works sometimes, and it doesn't work other times. This crazy thing, wait, hey, there's the root, hello, I'm over here. And so it's just not finding it. So this is a really good thing. And you can do actually chaotic dynamical system stuff with this, you know, depending on what your initial choice of root is, you know, how long is it going to take, and you can color the regions, make Mandelbrot set type things. You can do it all in Sage. If you think this is just for fun, easy stuff, here is the Riemann zeta function. It's going to take a little bit while to compute. And so this is the parametric plot of any given vertical line. And you can see I chose 0.5. And magically, it keeps on going through the origin because, of course, zeros of the Riemann zeta function probably are all on the line 0.5. But now if I change it a little bit, again, it takes a little bit to compute this. But you can see now they all get perilously close to the origin, but they all just happen to miss it. Every time it spirals around in the complex plane, it just happens to miss the origin, even if I get a little ways off. This is not a proof of the Riemann hypothesis. But just in case you thought I was claiming that. But it's still cool to be able to visualize, right? So, yes?
If an off chance that you do reach 0 by choosing some other real path, that is still not explored.
No. That's right. These are numerical approximations, of course. Yes. Yes, even if there was going through 0, I have not. And there's all kinds of other things. There's some that are built into Sage. Here is, well, that is a good point. If Gauss had had Sage, he would have done a lot because he tabulated. He said, like, on an off hour when I was bored and had nothing else to do, I would compute a chiliad of primes, which means he would go through 10,000 numbers and figure out which ones were prime. Like up in the millions, though, right? You know, by hand. Right? And Newton has this great quote when he was trying to use approximation techniques with Taylor series, basically, to compute roots. He said, I am ashamed to say to how many decimal places I carried my computations out at the time, having no better business. So I guess if you're bored, you calculate square roots to very, very high accuracy levels. So here's something cool. This is built into Sage, and you should check out the interacts that are built into Sage. There are lots of other places to look, and I've already mentioned those places. So Now, as we finish off here, and we had lots of questions, so we're just about out of time, I just want to let you know that you can actually embed Sage Cell instances in your web page. So you can interact and share the two things that today is about at the same time. And so, for instance, here is a Sage fan, Rob Beezer, and he has embedded Sage, analyze the Peterson graph. And so here we go. He's analyzing the Peterson graph for you right here, just like on his web page. This is just his web page, and he's embedded a Sage Cell instance in the web page. And so there you go. Or factorial of 30, right? I've done it too with lecture notes, and so, here's my lecture notes from day 33. And so if I do this, it's going to plot the prime pi function. And so the point is, if I can do it, you can do it. One of your homework exercises for next time is to take a look at one of these web pages and just to, so here's the prime counting function compared to the log integral. I'm just going to tell you there is a link for the basic instructions. I'm not going to show you how to do them, okay? Okay. So, but the instructions are easy if you have access to your HTML. Well, let's finish off with just listing a couple more ways to interact, and then we'll be done. There's a lot of lists on Google Groups that are very useful. There's Sage Support, where you can ask all kinds of help, and Sage Devel, where you can discuss general development directions. There are also research-oriented lists. Sage Combinat Devel is a place where some of the people in this room, and perhaps some of those watching out in TV land, as I like to call it, might want to. So product of Schur functions, extending tableaus, quiver algebras, some composition 1, 2, 3 broken, Sage Combinat days at Davis. So I mean, okay, yeah. So this is obviously research-oriented, but there's a lot of ways to interact on the internet that are not related to interacting via Sage, right? It's just interacting with other Sage users and Sage developers. There's also places to ask question and answer format things. So my favorite is probably ask.sagemath.org. If we go to the home, this is a list of all the questions, right? So there's all these questions that people ask, finding the maximum of a parameter. Somebody wants to know, can I find the maximum? And actually, the question they asked was quite hard, so I'm not surprised that they asked about p-adic regulator calculations. So you can have some very technical questions that you can ask on here. And it turns out that this person was able to get an answer that was pretty good enough for them, I guess, because they checked it. It was answered. So these are nice sites because then you don't have to go figure out who the expert is. You just put it out there, and some expert answers you. Stack Overflow and others also will have Sage-related questions. Finally, there's another way to share. You can share your love of Sage via social media. So if you are on Facebook, I encourage you to like Sage Math on Facebook. Okay. If you are on Google+, then you can +1 Google+. Here you can see some Sage developers working very hard at a house in Hawaii, I think. So here William shares, my experience with Sage rocks, that some physicist, I guess, was using. So all kinds of stuff on there. So if you have something fun, you can even share it with others, such as here's a snapshot of a panel at MathFest in Portland, Oregon, where some people who are Sage friends are sharing about various open source software. And apparently there's a new set of Intro to Sage videos coming somewhere in Chennai. So yeah, go figure. Yeah, I don't know. Who could have done something so silly? Anyway, so sharing and interacting via Sage. Do it. Thank you. Oh my goodness. Thank you. Spontaneous applause. Yeah, and you can read the homework yourself, but it's not as intense. So it gives you a chance to catch up on the homework from last time.
Second one is easy.
Yeah, the second one is very easy. And notice that number one, if you have a question, right? If you have a question,